Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to look ahead to an event that is coming up in the future. We are only looking a few decades ahead this time. For those of you who are familiar with my channel, you know that we take a look into the future for future events occasionally, although it has been a while since we looked into the future. We are going to be looking decades ahead into the future, but we are also looking at a date that has passed. So we are looking at the 27th of March, but for the year 2092. So here we go. We're looking forward to the correct date, and we are looking almost at the correct time. 7:45 was the time that I was told to look for, which is around here. We will be looking at the planet Jupiter and the position of a couple of its moons, and it looks like Jupiter is not above the horizon for us here in Ireland at this time, which is why, presumably, I was unable to see this event the last time that we took a look, because Jupiter simply isn't visible from Ireland while this event is occurring. So here we are taking a closer look at Jupiter, and here comes some of Jupiter's moons, and here we go. This is the event that we were supposed to see last time, and I believe it's an occultation, but we're going to have to see. So I think it is Ganymede occulting Callisto. Here we can see Ganymede blocking Callisto, and just here we can see Ganymede also sliding a little bit over Io. If we keep moving back, there's an occultation of Callisto by Io. And of course it's not a full occultation. Even if they were lined up perfectly, Io is so much smaller than Callisto and Ganymede, it wouldn't be able to block them completely. Whereas this conjunction, we're seeing it here at 7:53, Ganymede over Callisto, from a slightly different position that would be a true occultation. Ganymede is bigger than Callisto, and from this position it is in front of Callisto, making it appear even bigger. If we drift back to 7:45, around here is the time that we were told to take a look at. However, we are looking at these moons, we are looking at Jupiter from the Earth, and Jupiter is not an inconsiderable distance from the Earth. It is a considerable distance from us. If we take a look at our distances here, 5.6 AU. So it is further from us than it is from the sun, and it is 5 times further from the sun than we are. So Jupiter is significantly far away from us. And this makes a difference when it comes to time. So some of what we're seeing here is the time and the simulation speed, but when Stellarium is looking at things in the sky, it assumes that light is traveling. That light is taking its time to reach these planets from the sun and then reflect back to us, even at the speed of light. There is a significant delay, 5 times the 8-minute or so delay that we get from the sun. Light from the sun takes about 8 minutes to reach us. It'll take about 5 times longer to get all the way out to Jupiter, and from this position, about 5 times and a half longer to get all the way back. And that's something that we can change. So here we are looking at the view panel, the view control of Stellarium, and here in our solar system objects, simulate light speed. This essentially builds in a delay. It accounts for the 8 minutes that it takes for light to travel to us from the sun. It accounts for the even longer time that it takes light to reach us from Jupiter. So here we are. Light speed simulation has been taken away, and if we move back to 7:45 without light speed, we can see everything's still in quite different positions. Io here is in the shadow of Jupiter, which is why we can't see it, and there it is emerging from the shadow of Jupiter. So I think this is something nice to see as well. We're seeing, a half Io here, but this is because Io is passing into the shadow of Jupiter. Io's illuminated side is facing us and facing the sun. It has to. We're closer to the sun than it is. But we can see there that the shadow of Jupiter, it's not directly in line with Jupiter. We can see the shadow must be somewhere out here because we are seeing these things at a little bit of an angle. If I click on Jupiter here, 99.4% illuminated, not 100%. It is certainly not anywhere near its opposition, which is when we would see it directly behind the Earth and fully illuminated. Now, we've taken away our light speed, but we should still see these occultations happening. Yep, in a similar way because we are still at the same latitude. So we can see Ganymede here blocking off just the top of Callisto and just barely blocking off the top of Io there. But we can see these things are happening at a significantly different time. There's a difference of almost an hour here. And that is down to light speed. That is just how long it takes. When we're seeing these moons going through these conjunctions, these occultations, we are really looking into the past. So here we are, 5 minutes past 7 is when it's really happening. And if we turn back on light speed and we'll double check what time we see it, we can see things are very much out of alignment now. We'll have to keep moving into the future. And here's that same occultation, the very same occultation, and we're finally seeing it at 7:53, almost 50 minutes later. And that's our indication of how long light must be taking. It must take that long for light to reach us so we can see this conjunction happening. We can see this conjunction happening almost an hour after it actually happened, and that's just down to light speed. And taking a look at Jupiter's moons here, this is something where light speed really matters. Even though we're only looking within our own solar system, we need to account for light speed. Otherwise, we're going to be trying to look for these conjunctions, occultations, whichever you'd like to call them. We're going to be looking for them at the wrong time. Now, we are high on the planet, so we are looking down on Ganymede and Callisto here, presumably assuming Jupiter isn't too far from the ecliptic, which I generally assume it is not. That means that our position on the Earth, oh, that's the viewing window. We want the location window so we can change our location and see if we can leverage the effect of parallax to maybe make this occultation conjunction a little bit better. So it does seem to be a little bit better from higher on the planet. If we continue to move down on the planet, then we can see that our perspective is changing, but the amount of occultation that we're catching is more or less the same. Let's try changing our longitude rather than our latitude. We're still not getting enough of a difference here to be able to leverage parallax to give us a significantly different view. But what I do think we might be able to notice is that Ganymede is covering a little bit less of Callisto there than it appears to be from here, by just a little bit. We are, of course, looking at something that's quite far away, so we would need to travel quite a significant distance to be able to use parallax here. And normally, when we are using parallax, we're not just traveling a few hundred kilometers across the Earth, we're traveling 2 AU from one side of the sun to the other. So our position on one side of the sun, 1 AU away from the center, all the way around to our position on the other side of the sun, a whole other AU onto the other side, so 2 AU. By looking at a given object, usually stars, from one side of the year to the other side of the year, we're traveling a lot further, so parallax makes a much bigger difference. Traveling across the surface of the Earth, not so much. So we're going to move forward here again to 7:53. We've got our alignment, we've got Io, Callisto, Ganymede, there's other moons out there as well, and there is Jupiter's great red spot. So we're able to see Jupiter's great red spot here at this time if we're simulating for light speed. If we remove that simulation, well, the great red spot is even more in view. So we can see, hopefully, if I can get this out of the way, we can see Jupiter appearing to rotate by what would be about 50 minutes, a little bit less than 50 minutes, and that's just down to light speed. So this isn't going to be visible from Ireland. We've got a couple of minutes left here. Let's find out where it is going to be visible from. So we want to see Jupiter in the morning. Let's come back. There we go. Time has changed here a little. As you can see, UTC is being modified by 18 minutes instead of just being 00, because we're still not in our default location. There we go. I was wondering why the moons weren't lining up at the correct time. Here we are. 7:53. Perfect. So this is invisible from Ireland. We want to be somewhere where the sun is just rising while it's 7:45 here in Ireland. The sun has just set for us. So we've got our sunset terminator around here. All of this would still be in daytime. All of this would still be in nighttime. So we want to move back to somewhere that's roughly almost coming up to sunrise at this time. So let's take a look here from Southeast Asia, or East Asia really. We've gone quite far across the map, and it does look like Jupiter is just about above the horizon, not blocked by trees or buildings, not blocked by the glow of the sun. So here we are, first time, the exact first location that I thought it would be visible from, it is. So that's great. Often these things are a little bit tricky to line up properly, but we can see here even, I think the occultation of Callisto by Io, that alignment is maybe even cooler to see. And we can see it here at 4:30 in the morning from the other side of the planet, from the far east. I'll just double check where I clicked on the map. I do believe it is, yeah, the far east, definitely. So that's Jupiter just rising. Because we took a look up and down the planet, we looked at this view from different latitudes, I am confident in saying that this would be visible from everywhere along this latitude, from Australia as well as from Japan, and that is worth testing. So here we are. Here's Jupiter, much higher off the horizon because we are, I believe, a little closer to the equator. Yeah, we're only 26 degrees. So that means Jupiter and its moons, they're going to be above the horizon for this entire process, for all of these conjunctions and alignments, these occultations of the moons by the other moons. So that is an event that we have to look forward to coming up in 2092, really on the 27th of March at 7:45, 7:53 for us here in Ireland, but we're seeing it here on the morning of the 28th at about 4:30 from Australia or the Far East. Those seem to be the best locations to see it, because from Ireland, everything is still, unfortunately, under the ground at 7:45. So I hope that some of you get a chance to see this conjunction of the moons. Of course, it's going to be decades and it's not visible from here in Ireland at all. So I hope at least that you enjoyed this view, this preview of what that conjunction is going to look like. If any of you have future events that you would like to see, or hypothetical events that you would like to know if they are possible, please do leave a comment. Head to my website, queevinscontent.ie. You can leave comments there as well, wherever you would prefer. And most importantly, thank you for watching. I hope that you enjoyed this video. If you did, please do like it. If you enjoy this kind of content, then please subscribe to my YouTube channel. And if you'd like to read this information written down, you can do so on my website, queevinscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.